Let's take a look at a trickier example of adding rational expressions. Specifically, rational expressions that have opposites in their denominators. Opposites make things tricky when dealing with polynomials. However, there's one general tip that I have for you when dealing with opposites, and we'll see it here. Okay, before I can add these fractions, I need the denominators to match. So I'm going to break these denominators down, factor them in such a way so that I can build a common denominator. So if I were to do that, this first denominator is x plus 3 times x minus 2. My second denominator is not in descending order, so I'll simply rewrite it as negative x plus 2. Notice that that is still equal to 2 minus x, so I haven't changed it. And then, because my x in the front is negative, it's very common to factor that negative out, or pull a negative 1 out of this. So I'm not multiplying by negative 1, I'm pulling out a negative 1, factoring it out. And now I can see that my two denominators actually have this x minus 2 in common. Okay, now a lot of people make the mistake and think, oh, here's x minus 2 and 2 minus x, those are the same. They are not the same, okay? They're actually opposites, okay? So, when you have opposites, or if you think you have opposites, factor a negative 1 out of one of them, like we did here on the right, and see if what's left matches. So that's my tip when dealing with opposites. Factor a negative 1 out of one of them, okay? I see students mess this up all the time. They think I'm multiplying by negative 1, but I'm not. Okay? Alright, so now let's rewrite what we have here. So we have 2x minus 1 over x plus 3 times x minus 2 plus x plus 1 over negative 1 times x minus 2. Again, this equals 2 minus x. Okay, I have not changed it. I just changed the way it looks. Now when I build my common denominator, I have an obstacle. I have this negative 1 down here. The good news is, when you have a negative in a fraction on the bottom or the top, you can simply float it wherever you like. So, to avoid dealing with that negative 1 in the denominator, because I'm going to try to build a common denominator next, I'm going to float my negative 1 to the top of the fraction. A fraction is negative whether the negative is on the top or the bottom. Okay, alright, now you have to be careful when you say that. This negative 1 is multiplied by the entire bottom, so I can float it. Alright, you cannot move the negative around until you've pulled it out of the entire top or the entire bottom. Alright, so we have 2x minus 1 over x plus 3, x minus 2, plus, same thing on the top when I move that negative 1, it applies to the entire top. So now I have this. Okay, we're getting closer now. Let's take and copy the first fraction. Remember, my goal is to make my denominators match so that I can combine my numerators. So now I'm distributing my negative 1 on the second fraction on top, and now I can multiply my second fraction by a form of the number 1 to try to turn this x minus 2 into x minus 2 times x plus 3 so that my denominators will match. So clearly, I need to multiply by an x plus 3 here. But if this red fraction is going to equal 1, then the top has to be x plus 3 as well. Alright, let's see what our second fraction becomes now. When I multiply my two numerators, I multiply the blue numerator by the red numerator. So I am essentially using parentheses here, and that means I have to distribute my negative x to both, giving me negative x squared minus 3x, and then I've got a minus 1x here, so that's negative 4x. And then negative 1 times positive 3 is negative 3. And on the bottom, my denominator is x minus 2 times x plus 3, which is the same thing as x plus 3 times x minus 2, and I've accomplished my goal of making my denominators match. Since they match, I can add my numerators together. So I'm simply combining like terms on the top now because my denominators are the same. So my squared term, the only squared term that I have is negative x squared. So I'll write that first so that I keep my answer in descending order. Then I've got my x terms, so I have a positive 2x and a negative 4x. That's negative 2x when I add those together. And finally I have negative 1 minus 3, which is negative 4. And that's my new numerator in descending order. My denominator is the same, because that was my common denominator. At this point, I've combined my numerators to get this new numerator. That's our goal. Once we've gotten our new numerator, we should try to factor it so that we can potentially cancel factors on the top and the bottom. However, if you try to factor that trinomial, it doesn't factor. So we know that we're done here because nothing's going to cancel. So this is our final answer when we simplify this addition. Again, the point here was how do we handle if we see opposites? When you see opposites, factor this negative 1 out to turn one into the other.